Hello, how are you doing? I'm Adam Tilted, your dizzy dude, and this is Orbit at a Tilt. I'm trying a bunch of new things today, so bear with me. Great, let me know if you're here, say hello. What's happening here? Okay, alright, so I'm going in portrait mode today because IGTV came out. It's in portrait mode. So I wanted to see how this would fit in with that. We may continue to do it this way or not. I don't know. But let's talk about some stuff that's coming up in space news. So we've got tomorrow, Wednesday, Saturn is at opposition. That means that we are directly between Saturn and the Sun. And that means that it's the best time to view Saturn because it's the closest to us. Hi, Sharon. That it will be. And it's high in the sky all night long. So if you have a telescope or even a pair of binoculars, go check it out. Saturn will be up pretty much all night. And then on Thursday, Saturn will be close to the moon, which is always pretty. The moon will be full. So that's going to be nice. Full moon next to Saturn. Not a good time to look at Saturn through the moon, through a telescope because the moon will wash it out. Moon is at apogee on the 29th. So that means that it is furthest away from us in its orbit. And on Saturday, Mars will be near the moon. So if you want to find out where Mars is, take a look at the moon and it'll be just below it. And then what else have we got? Oh, this Saturday is a big anniversary of an incredible event. In 1908, an asteroid impacted a remote area in Russia, I think, Tunguska, and it didn't even make it to the ground. It exploded in the atmosphere, and it leveled, like, how much did it say? Hundreds of miles, just flattened. Ugh. So, yeah, that's why we need to start working on a plan to deflect some asteroids, because it's only a matter of time. Okay, that's all the news I've got. So let's get on with the topic for today, which is black holes. Oh, by the way, before I forget, please consider being a sponsor of the show. The links are in the description. If I can get some more sponsorships, I'll be able to afford to do some really cool stuff, like go to Johnson Space Center and attend some special events and give you some behind the scenes action, but I need your help to do that. So consider that. Links are in the description. So, black holes. For a long time, black holes were thought to be science fiction. They were predicted to exist, I believe, by Albert Einstein. I could be wrong on that. I get confused because there was a lot of debate about whether or not they really existed. But it wasn't until recently that we actually have enough evidence to say that, yes, black holes do exist. In fact, black holes are at the center of every galaxy, which makes me think that black holes might be the cause of the galaxy, but that's just my speculation. So let's take a look at how does a black hole form? Like, what is it? First thing that happens is a star is born. So I'm going to switch over to my little cartoon here. I'll draw some pictures for you. So we start off, and in space, there's just a bunch of dust all over the place. All right. These are subatomic particles mostly. And something happens. Either, a shock wave from a nearby supernova, or maybe the gravitational effects of some passing object, something causes these to be disturbed, and they start clumping together and forming a cloud that eventually gravity just squishes, 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 squishes until it gets down to a little point where it just can't take it anymore, and then a star is born. Okay, so a star has a core here, and that core is, well, first of all, a star is made up mostly of hydrogen, and a hydrogen atom looks like this. It's got one proton and one neutron. Okay, so very simplest kind of atom. But inside the sun, the pressure is so strong that it causes these hydrogen atoms to get squished together and turn into a helium atom. So this is helium. And this is hydrogen. Oh, sorry, you can't see that. Sorry, I didn't know you couldn't see that. Okay, so the hydrogen gets squished together to form helium, and this releases lots of energy. Lots and lots of energy. It's a thermonuclear explosion, basically. It's nuclear fission, because they're squishing it apart. Well, this process repeats itself over and over and over and over again. And then when there's no more helium, no more hydrogen left, then you start to get some heavier elements. So, you'll get carbon, you'll get oxygen, all those things. And eventually what happens, switch back to the pad. Eventually what happens is you have the sun, or a giant star. This would have to be a star that's much, much bigger than our sun, okay, in order to create a black hole. And inside the core, it's compressed all of the atoms it can until it makes lead. And lead equals death for a star. Lead does not release energy. Oh, I forgot to show you something. The reason why this is important, that it releases energy, is because the sun, it's got gravity pulling in, but the radiation from the nuclear fission inside is pushing out, and it balances. Okay? So that's why it's able to do that. Now, at some point, it runs out of that, and it gets lead. Lead does not release any energy, so all that gravity is not being pushed against anymore. And so the whole thing just compresses. It just goes down into a spiral into a single point. And then, boom, 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 it just explodes in a supernova. And at this point, when it explodes like this, that is when all of the elements are made. Because that huge explosion, creates enough energy to force those atoms together that, wouldn't normally be able to do that. I forgot to share, so I'm going to do that real quick, and if you don't mind sharing, that would be awesome. Great. All right, so we've had the star, the dust clouds collapse, gravity, boom, explosion in the middle. So you've got this gravity pushing in, radiation pushing out, and that's keeping the star in balance until the radiation inside runs out, and then the gravity just scrunches it all together. And that causes a shock wave, boom! And then that creates all the elements and flings them out into space to form another dust cloud that will eventually become another star or planets or something. Or us. Okay? Now what's left over depends on how big the star was. If it's a big star, then you'll get a neutron star. And neutron stars spin. They're very interesting. I'll do a whole nother show about neutron stars. But if they're huge, super big stars, then you get a black hole. Because when that gravity takes over, all of that material gets pulled into the center. And after it explodes, the gravity is enough to pull it all back in. And the gravity is so intense, it warps space-time so much around it that anything that crosses what's called the event horizon cannot leave. All right. Now, you may have seen depictions of black holes in science fiction movies or whatever as like a drain in a sink or something, and that's not at all what they are. There is an object in there. It's small. It might be the size of an asteroid. It might be the size of a basketball. Don't know. But its gravitational influence is much bigger than its surface, and that part in between, what's on the outside of that gravitational influence, is called the event horizon. Now I want you to imagine this. You're in a canoe. You're going down a river, all right? And you get to a waterfall. You don't know there's a waterfall at the end. All right, so you're going along, and the water's getting faster, but you don't necessarily notice. And if you don't stop before it's, at some point, no matter how fast you go, you're not going to be able to stop yourself from going over the waterfall. It's too strong. That's the event horizon in a black hole. So black holes are not like a suction machine. They don't. But anything that does go across that event horizon is not coming back out. Now, what happens when it's in there, we don't know. There are a bunch of theories, but the truth is we have no idea. No idea. I mean, it wasn't that long ago that we thought that they didn't even exist. So we have no idea, and there's no way to, even if you could somehow get into a black hole to measure something, you wouldn't be able to get back out, at least not with the way we understand the current laws of astrophysics. So that black holes are weird. They're weird. And when you start thinking through scenarios that involve black holes, boom. All right, now, but black holes do not last forever. They do evaporate very, very, very slowly. Very slowly. And it's a process called Hawking radiation because it was predicted by Stephen Hawking. And it has since borne out some evidence to be true. So a little tiny bit of radiation leaks out of the event horizon when something enters. It's a little more complicated than that, but that's basically what happens. And so over, I don't know, billions of years, then it'll evaporate enough, and then it'll explode, theoretically. But we will be long gone by then. So that's the basics of black holes. Now, black holes, there are a lot more to say about it, but I just want you to understand the basics. If you have questions about black holes, please let me know, because I have more knowledge about them, and you probably have some questions that I didn't cover. I just didn't want to overwhelm you with a bunch of black hole information. Let me just check to make sure I included everything. And yeah, I did. So, oh, you know what? I made a mistake. I made a mistake when I said iron. I meant lead. Whoopsie. That was wrong. I lied. It's not iron, it's lead. Lead does not produce energy when it is created. It's also why it helps us protect us from radiation. So that makes sense, right? Okay, so thanks, Sharon. I appreciate that. And if you, oh, I did say lead. Okay, good, good. Because I had it written as iron in here, and then I realized that that was wrong. Good. All right. Thank you. So, thanks for stopping by. Don't forget, if you thought this was interesting, share it with your friends. And if you have ideas for future topics, let me know. Don't forget to like and follow Adam Tilted TV. Right now, it's called, the name of the page is Thoughts from a Dizzy Dude, because Facebook won't let me change the name, but I'm working on that. But the username is Adam Tilted TV, and that's what we're going to call it. So, all right. Yes, Sharon, let's chat offline, and we will talk about my Ecamm experience. Ecamm is a software I'm using right now, by the way. It's for Mac only, and it's amazing. I love it. I love it. And this is, they now have this portrait feature, so way to go, Ecamm. All right. Thanks for stopping by again. I will see you tomorrow at 11 a.m. Eastern Time for What's Up Wednesday with Danica. So tune in for that. And until next week's Orbit at a Tilt, don't forget to look up. Bye. Bye. It's not working. Oh, here we go. No.